Hi everyone, we're going to look at domain and range for functions. The domain and the range describes the x's for the domain and the range is all the y's. So domain you can think of as all the inputs and the range is all the outputs. So if it's a simple example, say like 1, 3, and 2, 4, say that's all our function was, then your domain would just be all the x's, 1 and 2, and your range would just be all the y's, 3 and 4. And that would be a very easy way to write the domain and range for a very small function of just 2 points. For graphs that are continuous, more than just 2 points, we're going to have to use intervals to show all of the x's and all of the y's. So we've got different ways to write these intervals. We've got what we call interval notation. And then we've got inequality notation. So say I want to say all the numbers between 2 and 5, but not including 2. So I could write it using interval notation like this, 2 and 5, but I want to include 5 and exclude 2. So this little square bracket includes, and this open bracket or parenthesis excludes. So it's not included. The 2 is not included. That's interval notation, or we could use inequality notation, and that would be like this. X is in between 2 and 5, but it's including 5, so we put a little line down there to include it, and not including 2. So those are different kinds of notation to show a range of values between two numbers. Again, we're looking for the domain and the range, so the inputs and outputs for our functions. The best way to see this for a continuous function is to graph it. So I've got here already graphed this function over here. You really have to know for the domain, how far does it go left and right? And this should go on forever. There's no arrows on here, but it does go on forever. I just had to kind of cut that out of an actual full graph. So this function here has a vertex at -2, -3. Which you can see in the vertex form of this function because it's the opposite of this value, and then that value is the y value. So that's the vertex. That will help us with the range because the biggest y value is at -3, and then everything below it would also be included in the range. So let's do our domain first though. So when you think about domain, I want you to think about all the things that can't work first, because usually it's easier to find all the things that don't work versus all the things that do. So looking at this function, are there any numbers that are not going to be able to plug in here? So the short answer is no. There's nothing that I can't plug into this. I can plug in decimals, negatives, positives. It makes no difference. Everything's going to be able to work. There is no restrictions on this domain. So the domain here is going to be everything. We're going to call that all real numbers. You could write it like this, or you could say everything between -infinity and infinity. That would be interval notation. Or we could write it in inequality notation like this. Now you'll notice here I didn't use any square brackets or I didn't put the equal sign on here because you can't really equal infinity or negative infinity. They're not numbers. They're like a destination that we never quite get to. So you can't include those in either notation. That's how we do the domain. It's basically how wide your graph is. And the graph can go forever to the left and right. There's no restrictions on this one. It's just a quadratic. Everything will be allowed to plug into this. For our range, that's all the possible y values that we hit by this function. So the no y values are hit up top here. None of these y values are used in this function. The biggest y value, like we already said, is at -3 here. And then everything below it is in the range. So we need to say that as our range using both notations. So the range is everything basically less than -3 or equal to -3. So be careful how you write this. So we have to always go smaller to bigger for the interval. You cannot write it like this. This doesn't make any sense because that's bigger than that. So it doesn't make any sense. You got to go smaller to bigger. So like in this case, bottom to top for the interval. So -infinity to -3 would be our interval. So -infinity to -3. We can include -3 because we do actually reach it. Only time you wouldn't include it in this example is say it was an open circle at that vertex, then you would not include it in that notation. And then for inequality notation, same idea. Negative infinity, don't want parentheses there, is less than y, which is less than or equal to -3. That would be inequality. You could just write this as y is less than or equal to -3. That is the same thing. These two things are the same thing. Either way, whatever makes more sense to you. For the next one here, we've got -6 times the square root of x. And as you can see, it kind of stops at this point right here. There's nothing negative, no possible negative values of x here because you can't do the square root of a negative. So here for the domain, I want you to think about, again, what doesn't work. So we can't do a square root of a -5, for example. That's not going to work. Or square root of a -1. These are not real numbers, so they're not going to work for our domain. The smallest value that works would be 0. You can do square root of 0. That's just 0. So for our domain here, there's nothing to the left, but it does continue on to the right forever. So you want to say everything bigger than or equal to 0. So you write it like this, including 0 to infinity. That would be interval. Or we could say 0 is less than or equal to x, which is less than infinity. Inequality notation. Or again, we could simplify that a little bit and just say x is bigger than or equal to 0. That's the same thing. Or 0 is less than or equal to x. These are all the same thing for inequality notation. For the range, the biggest y value is up top here at 0, and then it goes down from there. So again, when you make your range, make sure you always do the smaller to the bigger. So we wouldn't say 0 to -infinity. It doesn't make any sense, so don't do that. You've got to do smaller to bigger. So -infinity to 0, including 0, not including -infinity, that would be interval notation. Then inequality notation, very similarly, like this. Again, you can simplify this, though. Again, you could just say y is less than or equal to 0. That's how you'd show all the possible range values for this function. When you're doing any domain and range question, make sure you graph it first so you can visually see what's happening, and then you can see from there what x's work, what y's work, and those will help you write the domain and the ranges.